Hello, everyone. I hope you're doing well. Just to recap what we did last video, we talked about kind of like the fundamentals of using a statistical program like R, specifically using the concepts of an input, a function, and an output, and also briefly mentioning the concept of functions in R. So before we really get into working with large data sets, I just want to quickly go over in this video the different types of variables that you can find in your data tables and how to make sure that R sees them the same way that you do and treats them the same way as you do, because there are certain functions in R that specifically are meant for a certain set of variables. And just to recap something that you might have learned previously in a statistics course, um, or medicine and society. Um, the first there, the first two main types of data are categorical variables and numerical variables. Categorical variables are ones that really kind of only come in a fixed number of values, and an example would be dead or alive, obese, overweight, normal weight, underweight. Whereas numerical variables are also known as continuous variables, or there's a section of it called continuous, but basically, they can have a number between a certain minimum and maximum, and the numerical value, actually refers to its meaning. So, an example of the two different types of numerical variables are continuous, which can be, as it says here, any numerical value. It could be, it doesn't have to just be like integers, whole integers, and that could be something like birth weight, or you can have a discrete numerical value like the amount of pregnancies you've had. And then in categorical, there are nominal and ordinal types of categorical variables. An ordinal one is where there's an underlying order to the variables. So an example of that would be like the values. If you have a variable that has three set of values, which is low, medium, and high, there's a order to those variables that relates one to the next. Whereas in nominal, there's no inherent relationship between one value of that variable to the next. So an example of that would be like names. Like there's no if you have a list of someone's name, there's no order to what a name could be. So now that we kind of went over what the different types of data there are, we can talk a little bit about how R classifies its own data and how these fit within R. So within R, there's no real differentiation between discrete and continuous numerical values. They're all just numeric, and it treats them the same way. And so before I actually get into that, sorry, I just want to open up I don't know if I showed this previously, but there's a data set that is inherent to R. It is built into it. So, and you can always call upon it. And I just want to, I think it'd be much easier to understand if I talked about these variables with an open up and a data set opened up. So, it's going to be the iris data set that is built into R, and it has some information, some data on experiments with flowers and flower measurements. So I'm just going to call this flower data and assign, and I'm going to make it a storage object, and I'm going to assign it the value of the iris data set that is already in R. So you just, you make, this is the code you're going to use, press enter, and now you have this data set logged into R that you can just call upon like this. So I clicked on that, and the data set popped up in the script, the top left window. And you could see here that there are different types of data sets. I mean, different types of variables. So sepal length, width, petal length, width. These are, at least to our eyes, what they appear like now. These appear to be numeric, and specifically, these would be continuous because they're not just discrete 1, 2, 3, 4. You have decimals. Then you have species, which appears to be a categorical variable because there's no numbers and it's just giving you the names of the species, so there's no inherent order to them. But we can, we could actually see how R sees it, just to confirm. So we can double check to see how R sees a variable by using a function called is dot, and then it's basically you're asking R a question like, is this variable that you're going to specify, is this variable a numeric variable, or is it a character variable? And a character variable is just synonymous with categorical. It's used the same interchangeably. So let's check if sepal length is numeric. So we're going to use the function is dot numeric, and then we're gonna you won't really have to do this, but we're just gonna give an example. So we're gonna do the way you test it is you put the object that you want to see that's going to be answering this question, is this object numeric? So we're going to do the data set that we have, so flower data, but then we specifically only want to ask if sepal length is, and the way that we isolate it in this case is just to use the money symbol, and then all these pop up. We'll just do sepal length, and we'll press enter, and it said true. So that lets us know that this area is true. That this whole variable is true. And then let's say we tried it with the species. You'd expect that since the species looks like a character value or categorical, this would give you the response of false because it doesn't satisfy because it actually is not numeric. So let's say it's false. So let's do species. So it's going to ask the question, is this basically this function is saying, asking the question, is the species variable from the flower data set numeric? Okay, press enter, and false. So just like we expected. And you can do the same thing with is character as well. So like is character, is that character tests to see if the variable that you're looking at is a character value. And if we do it with the width, this column here, you'd expect it to be false because these are all numbers. However, so the general rule of thumb is that anything with numbers is going to be a numeric value, or is going to see a numeric, and anything with text like this is the character values is going to be a character. It's going to see it as a character value. However, there's a way for numbers to be seen as character, and you'd want to do that like if you had a zip code. Zip codes don't really have any meaning. Their numbers don't really have meaning. They're just a way to identify different regions. So the way that you could tell R that this is a character, that this number is a character, is by using the function as character. So let's say we have like 3 zip codes. We have 1-4, and just like some Buffalo zip codes, 14209, 14208, 14207. So we'll just do zip codes, zip codes, make a storage object called zip codes. just so we get to refresh our memories of how to make a storage object. And we're going to do especially one that's a vector. So a vector is something that only has is a lit. It's kind of like a set of values that all have this that are of all the same type of value. So it can either only be numerical. A vector can only have numeric numbers. It can only have, or I mean, it can only have numeric values, or it can only have character values. It can't have both in the same one. So we'll do 14209, 14208, and 14207, and we'll make this object. So now, at this current moment, as you can see here, R thinks that all these numbers are numeric. However, what we're about to do is we're going to change them to character. And the way you do that, like as I said, is just as character. So we'll create a new object called zip code char, and we're gonna just do as dot character, and then we're gonna put the object in that we want to become a character. So we'll just do zip code. We want all these values to become characters. So highlight it, press enter, and now we have zip code character, and you can see two different things. So you see that the type of value here is different. It's one from numeric to character. CHR is just character, and then each number now has a parentheses around. It has a quotation mark around it. And if you ever just want to like write down a character value in the code, you have to put parentheses around it. So if you try to like if you try to assign an object a character value, you have to write a parentheses around, like quotation marks around that value. So example, let's say I just want to make I wanted to make a object called favorite sport, and I want to assign it assign it football. I would just press enter. If I press enter, it's gonna say enter error object football not found. Because if you don't have parentheses around a like character word, like a word like football, it's gonna think it's a storage object, and if it's not in here, it's or just like built into R, then it's gonna give you that error. So the way that you tell that it's not an object or that it's a character value is you do the same thing except copy, paste, that, and then as I said before, do parentheses around it. I do enter, and now you have a new object, favorite sport, and it has character value football. And you can do the same thing with the numbers. Instead of going like as character, instead of doing this step, we could have just did this with zip codes and then did a parentheses around each one. So that's really it for character and numeric. If we wanted to so that's character numeric. So the next variable is a factor type of variable or value, and that is essentially, it's kind of like a mix between numeric and categorical, in that there's a set amount of values for a possible variable. However, each value has a relation to one another, and that's kind of like the ordinal variable, like I said before. So it'd be like low, medium, high. That is a fact. You want that to be treated as a factor variable in R, because there's a meaning. There's an inherent meaning between those values. Like, and I'm not going to show you how to do it here, just because it requires a function from the next video. But you can easily change a character variable. Like, let's say you wanted to change this whole column from a character to to a factor variable, it's very easy. It just requires like one function. But yeah, that's what a factor variable is. The last type of value you can have in R is called I guess it's an NA or a missing value. I get yeah, it's really called a missing value. Um, and that's like, let's say you just had like a square or like a cell in your data set that didn't have a value, and you try to upload that to R. Instead of it just being like an empty block, like instead of this being an empty block, it just say NA. And if you try to do anything with NA, like with something with an that has a value of NA, it's just it's gonna um return, or just gonna return like error, like can't do something with NA, like um however, R knows when something has a missing data, when like a value has a missing data as its value. And you could use that when you're using R and trying to clean up your data, by incorporating the function is dot NA into your um, code, and that will basically, you could say, if this code is true. So let's say you put in like your data into this parentheses, and there's a cell that had an NA value. R will let's say you said like remove. This isn't the actual code, but let's say you just say like if is.na is true, because remember these is dot functions give you back a response true or false. You say if it's true, then delete, and R will basically just get rid of those values from your data set. Let me see if there's anything else that I think we should go over for this. I don't think so. I think that really covers to an extent everything. However, actually, there is one thing I wanted to show, kind of just like what happens when you try to um, incorrectly use a function or an operation in R with the wrong type of variable or wrong type of value. So we talked about how there's a difference between zip code and zip code character, because these are no longer seen as numbers, they're seen as kind of names. So if we just treated them as numbers, if we use the one that's where they're treated as numbers, you can do numerical operations to them, like addition, multiplication, subtraction. So I believe if you just do the storage object zip code plus 2, you should add 2. You'll be adding 2 to each value in the function. So yeah, perfect. So the first value 14209 had 2 added it. This but yeah, each value in the vector had its own individually got 2 added to it. However, if we try this with the character version of the zip codes, what you'll find is that you'll get an error, because a non-numeric argument to binary operator, that just means you're using a non-numerical value and you're trying to add a numerical value to it. So it's just not going to work. It's going to say that it's impossible, that the answer will be meaningless. So it'll give you an error. So that's basically it. That kind of is like just to solidify what we were talking about the different types of variables and how R treats them. As I said before, vectors are a collection of values that all have to be of the same type. If you want something that has different types, like you want, which is basically what a data set is, this data set has both numerical data and observations, but also categorical. You basically are going to be using a list, and the list can have different types of variables. But fortunately, the coding community has already made these functions that are very easy to work with. So you don't really have to work with lists and vectors as much, but it's still good to know that there's that differentiation. Excuse me. So yeah, that's really it for this video on the different types of variables in R. Um, it might be a little confusing at first, but there are definitely a lot of resources online. Sorry. There are resources online that can help you kind of better explain the differences between these variables. Sorry, dying here. Um, yeah, so that's it. Next video, we're actually gonna open up a data set and we are going to start using some functions that are very relevant to working with data set and data cleaning. And thank you for coming.